Okay, so we have solved exponential functions, which are things that look like this. 3x plus 1 is equal to 7x minus 2, whatever. Okay, by logging each side. That's an exponential function. Now what we're going to do is we're going to solve logarithmic functions. So questions that already have logs in them. All right? And there's two types that you will see. There is either the kind that have logs on either side. All right? So if you have logs, a log expression equaling a log expression, single term, like this, it's the same as when we solve stuff like this. 2 to the x is equal to 4 to the x plus 1. Or sorry, 2 to the x plus 1. What did we do in that case? Because the bases were the same, you just have to make those match, right? And then it works out. It's the same thing for logs. As long as you get this log base b and log base b, if you make the bases the same and it's a log equaling a log, all you have to do is equate the arguments. Okay? So equate the arguments. That's one kind. The other kind is when you have a log equaling a number. So in this case, the number is q. Okay? If you have this, then what you do is you change to exponential form. Okay? Now, not every question is going to be written as log of p is equal to log of q. You have to get it to that point, all right? Or log of p is equal to q. You have to manipulate them to get to that point, and then when you get to these two instances, then you use either equate the arguments or change to exponential form. Okay? Are we ready? Here we go. So here's our first one. Log 5 of x plus 1 plus log 5 of x minus 1, or x minus 3, is equal to 1. First thing you have to do is combine the logs. So that's what we did with our log rules, where if you're adding, it's the same as multiplying the arguments. And I hate it when they write this stuff out, but that's okay. So basically, I multiply the x plus 1. So I get this. I put the x plus 1 times x minus 3, all log base 5. Okay? Now we have a single log of some stuff, the argument, equals a number. So that matches this one here. So you change to exponential form. Do you remember how to change to exponential form? This base moves over and kicks that up to the exponent. Do you remember that? You did it on your quiz the other day. All right. So that kicks it up to 5 to the power of 1. Well, we changed to exponential form, so that gets rid of the log. All right? So now you have this. And this is grade 11 math. Because what type of equation is this? It's a quadratic. How do you solve quadratic equations? Well, it's already factored, but what do you have to do first? You have to get everything to one side and make it equal 0. But you also have to FOIL the brackets. So the first step is FOIL the brackets. X plus 1 times x minus 3 is x squared minus 3x plus x minus 2x minus 3 is equal to 5. You can write 5 to the 1 if you really want to. Okay, this is a quadratic expression that you would have seen in Math 11. You can't have it equal 5. It has to equal 0. So move the 5 over. So I get minus 8 is equal to 0. When you get a question and you don't know what to do, you look to the blue shirt that says factor it. What multiplies to negative 8 and adds to negative 2? Which one's negative? So it's x minus 4. X plus 2 is equal to 0. So what does x equal? Is that okay? Yeah, this is why we got to check it. Okay? So this is not the end. You need to check your answer. Okay? And you check your answer by putting each one back into the original. To see, because what numbers can you not log? You can't log negative numbers. And what I mean is, well, you'll see in a sec here. So let's put, let's write it down. Okay, so plug both into original to check. Now look, you can just do this in your head. I'm going to do it for the first time. I'll write it out, but normally you can just plug it in do it in your head, okay? You don't have to show your work. So if I put 4 into this, I get this. 4 plus 1 plus log 5, 4 minus 3 is equal to 1. What's 4 plus 1? 5. So that's positive. So I can do that, right? I can log the number 5. What's 4 minus 3? 1. Can you log the number 1? You can. It's 0, but you can still log it. Okay? So 4 checks out. 4 is good. Now, if we put negative 2 in, I get this. What's negative 2 plus 1? Can you log a negative number? No. So it blows up right there. If it fails in any one of them, then you have to throw it out. But it also fails in this one because negative 2 minus 3 is negative 5. Okay? So can't log a negative. Therefore, ignore x equals negative 2. Therefore, your only answer is x is equal to 4. Yeah. Does x always have to be negative? I mean positive? No, x can be negative. Like, for example, I'm going to show you one of these. But if I had something like this, log of x plus 7, and we got negative 2 as one of our answers. If I put negative 2 in there, I get 5. You can still log that, right? Because if you think about it, this 7, move the vertical asymptote to negative 7. So an x of negative 2 is here, which is still in our domain. Okay? What if you have like 2 logs, so 1 is negative, 1 is positive? If 1 is negative, the whole thing blows up. It has to be positive in both of them. Okay? So in this case, you only get one answer. Sometimes you will get one answer. Sometimes you will get 2 answers. Sometimes you will get no, not 0. No answers, right? 0 is different than no answers. Wait, what if you have a cubic? Oh, we're not doing those. But you could have more than that. You could have 3 answers as well, right? If it's a cubic. Okay. Flip the page, please, people. So in this case, 2 is called, negative 2, sorry, it's called an extraneous solution. You might remember that from last year. If it's extraneous, it's in a solution that does not work. Okay. Let's look at this. Log x squared is equal to log 16, and 2 log x is equal to log 16. Let's solve this one first. We have a log equaling a log. So if you go to the front, if you look at the front page, you don't really need to because I have it. That means if you have a log equaling a log, what do you do? And the bases are the same. You just equate the arguments, correct? So on this page, our bases are the same. We have log equaling log. So I just have to say x squared must equal 16. So if you square root it, x is equal to? Who said plus minus? Plus minus 4. Okay? Correct? All right. Now this one, 2 log x is equal to 16. What do we want to do? You can't get rid of the logs yet because we got the stupid 2 in front. So you can move it up. And then you equate them. And you get? Okay, so you get plus minus 4. Now, you have to check your answers. So if I check positive 4, that's clearly going to work, right? But if I check negative 4, what do I get? Can you do a negative? No. You check it with the original. Okay? So, this doesn't work. Nope. Therefore, x only equals 4. This one, if I put either 1 in here, put positive 4 in, that works. If I put negative 4 in, square a negative, you get a positive. So they both work in this case. So you need to check it with the original. Okay? Not once you... Whoa. Where'd it go? What the hell? Oh my gosh. Always check with the original, okay? Not once you manipulate it. You have to check with the original. And if you looked at the graph of these, if you graph log x squared, it looks like this. Okay, you get both sides of it. If this is the graph of log of x squared, I'm not going to ask you to do this. If you graph log 2x, you get that. You only get half of it. And then log base or log of 16 is just some number. So that's log of 16. That's log of 16. So basically when you're solving these, what you're finding is the intersection point, 4, and negative 4. That's what you're actually doing when you're solving it. You're saying you're saying that this function, which is the red, equals this function, which is the green. And where do they intersect? They intersect at negative 4 and 4 for this one. For this one, you're saying this function, 2 log x, equals log 16, and they only intersect once. Okay? But the key point here is check your answers with the original, not once you manipulate it. Okay? All right. We'll do one more, and then I'll give you some time, and that'll be it. So flip the page, please. 299. Okay. Log 4x plus 1 minus log 4 2x minus 3 equals log 4 8. What do we do? Combine the first two. If you're subtracting, you are dividing. So okay. Now what? Yeah. So because it's a log equaling a log, and they're the same base, essentially you just ignore them and equate the arguments. So I essentially just go x plus 1 over 2x minus 3 has to equal 8 for this to be a true statement. And then you algebra it. So multiply out the 2x minus 3. So you could say 25 over 15, or you could reduce it to 5 over 3. Does that work? 5 over 3 is greater than 1, right? So I know it'll work in the first bit because we're adding. That's okay. 5 over 3 in this one. What's 2 times 5 over 3? 10 over 3, which is 3 point something. You can do it on your calculator. 3 point something minus 3 is point something. Positive. That's all I really care about. So it works. So it's good. All right. Last one for the day. What do? Yeah. So you want to combine the logs. All right. If there's a number by itself, leave that over on one side and get this log over here. So log 6x plus 4 plus log 6x plus 3 is equal to 1. Those are being added, so we are a log equals a number. So what do? Change to exponential, right? So this moves over, and I get x plus 4 All right, can you solve it from here? Go. And I'll do it, and we'll see if we get the same answer. You get it? We're ready? There's only one answer. What is it? -1, because you have to check your answers. You get -1, -6. -1 works. -1 plus 4 is a positive number. -1 plus 3 is a positive number, but -6 plus 4 is a negative, so the whole thing blows up. So the only answer is x equals -1.
Is this one of these things where it's like actually illegal or like a
No, it doesn't work. It's actually illegal. You mean I'm not going to tell you later on that you can do this? No, this one doesn't work. You mean like square roots of negative numbers where you can have imaginary numbers and stuff like that? Yeah, no.
There's not some mathematician.
There might be something way above that I know, but as far as I know, no. All right. I need you to do 1 to 6, peoples. Oh, is it? I think it is.